everybody, welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to solve some more systems of linear equations, and this time we're going to use a method called elimination. So this is a really cool method, and some people think this is the easiest way to solve systems of linear equations. So hopefully you're excited. I know I am. Let's go and review what we did in the last video when we did substitution of the three cases, right? We have either one solution, no solutions, or infinitely many solutions. These are the three cases when we're solving systems of linear equations. And these three cases still hold for elimination, right? It doesn't matter what method we use, graphing, substitution, elimination. These are the three cases. So let's go and review it in case you didn't see that last video. With one solution, we get some number, and then we're able to substitute back in and get some other number, right? We basically have a solution. We have numbers for x and y. That means we have one solution, or we call this independent and consistent. No solution. That means we get something that just doesn't make sense. That is just never true. 2 equals -4, that's never true. That's nonsensical. So no solution. In other words, inconsistent and independent. Infinitely many solutions, we get something that's always true. -12 equals -12, that's always true. 10 equals 10, 5 equals 5. If we're left with something that's always true, we say it has infinitely many solutions, and we also say dependent and consistent. Consistent just means there's at least one solution. So the only case that's not consistent is this case where there's no solution. That's why we call it inconsistent. And independent just means they don't share all solutions. So the only case that's not independent is infinitely many solutions, and that's why we call that dependent. So let's go and get into the process of elimination. Alright, so how elimination works is we can set up our linear equations like this, one above the other. And what we're going to do is we're going to add down. So I'm going to add x plus x, 2y plus -2y, and 8 plus 4. And what the goal is I'm trying to eliminate one of my variables. This is why we call it elimination, right? So I'm trying to get rid of either x or y. So I'm left with just x's or just y, so that I can solve for x or y and then go back and substitute back in to solve for the remaining variables. Similar process to substitution, but not quite. So what jumps out to me when to use elimination versus substitution, because you can use both to solve any system of linear equations. It's up to you which one to use, unless you're told which one to use on an exam or something, right? But what jumps out to me is I have these set up where I can cancel the y's right away. They are additive inverses of each other, meaning when I add 2y plus -2y, I get 0, and I get rid of the y's. I cancel the y's. So that's what jumps out to me. If I were to see this, I would immediately do elimination, but that's just me personally. So let's go ahead and do it. I'm going to add down. X plus x is 2x. 2y plus -2y is 0, right? Plus 0. I'll just write the plus 0 just for fun. Equals 8 plus 4 equals 12. Okay, so now I just have 2x equals 12, so I divide both sides by 2. And I have x equals 6, okay? So see how that was kind of simpler to get my x value, okay? It took less algebra, and it works out like that a lot with elimination. But now the only part that's, you have an advantage with substitution is I have the variable already solved for when I go back and plug this in. In this case, I don't have it already solved for. So I'm going to substitute in 6, and I'm going to plug it into either one of these x's. I'm going to choose this one. So I have 6 minus 2y equals 4. And now I basically just solve for y. So I'm going to subtract 6 from both sides. Minus 6, I get -2y equals -2. And if I divide by -2, I get y equals 1. So my final solution is x equals 6, y equals 1. I could write this as a point, 6, 1. But yeah, now you see that substitution and elimination both have their advantages and disadvantages. Elimination can be easier in the beginning with the algebra, but then sometimes going and substituting back in takes a little bit more work, but not much. I mean, they're about the same, I think, but a lot of people prefer elimination. So let's go and do some more examples. So sometimes you need to do a little manipulation before you can add. Like, look what happens if I try to add these. I don't eliminate x and I don't eliminate y either. I'm left with x and y, which is a big problem. I can't solve that. I need to eliminate x or eliminate y. So what I can do is I can multiply both sides of either this equation, or both sometimes. You may have to do both. But I can multiply both sides of the equation by something so I can get it set up to where when I add them, I cancel one of my variables, right? So there's some options here. I can multiply both sides by 2, and that's probably what I would do personally, because negative 2y plus 2y gives me 0. I'll get rid of the y. But you could also multiply both sides by negative 2, because that would give you negative 4x plus 4x, and that would get rid of the x. So either way, there's more than one way to do these, and it may just take some practice for you to be able to identify and figure out what you need to multiply both sides by, and you may just have to do some practice. So I'm going to go ahead and do that, though. I'm going to multiply both sides by 2. And again, 0 times 2 is still just 0. So I'm going to rewrite my new equation down here. 0. Here I got 4x minus 2y. 4x minus 2y. Now I can add these down, right? 4x plus 4x, that's 8x. Plus 2y minus 2y, that's 0. Equals 12 plus 0, that's 12. So now I have 8x equals 12. I can divide both sides by 8, and that will give me the x by itself. So I have x equals 12 over 8 as my solution for x. This can actually be simplified if I multiply top and bottom by what, 1/4? Or in other words, divide top and bottom by 4, I get, what do I get? 3 over 2. That's the common factor. They share a common factor of 4. So x equals 3 over 2. I can substitute this back in for x. These might be little ugly numbers. I'm going to do it for this one, 4x minus 2y. I'm going to do it for that one. But again, you can substitute back in for either one. They both look equally as complicated in this case. And again, this is the disadvantage to elimination. So, but let's go ahead and do it. 4 times 3 over 2 minus 2y. I'm solving for y, right? Equals 0. So now what am I going to do? 4 over 2, that's 2, right? 2 goes into 4 2 times. 2 times 3, that gives me 6. So I'm going to rewrite this up here. 6 minus 2y equals 0. I'm going to move this 2y to the right side so I can solve for y. So I'm going to add 2y to both sides. This is getting a little messy. I'm sorry, I'm getting disorganized. X equals 3/2, so I'm going to rewrite that down here. That's what I plugged in, and now I'm solving for y, right? X equals 3/2. Sorry about that. 6 equals 2y. That's where I'm at now. Got a little disorganized there. Sorry about that. Setting a bad example here. All right, divide both sides by 2, and I get y equals 3. So this is actually my solution. I have one solution for this system of linear equations, and I can write this as a point if I want. 3/2, comma 3. But yeah, this is my solution. I have one solution, so this is independent and consistent. All right, so if we're gonna break down elimination into steps, this is what I would break it down into. First step, which we didn't have to do because usually you're given the equations in standard form, but just in case you're not, they need to be in standard form. And I didn't write down what standard form was, so I probably should do that. That's ax plus by equals c. Okay, where a, b, and c are actually integers in this case. Standard form, this is what we usually see them in, but maybe your teacher could throw you a curveball and you'd have to get it to standard form. Okay, step 2, multiply to get opposite coefficient for x or y. Remember, I need to either cancel x or cancel y. I need to eliminate one of them. So I have to multiply both sides of one equation or sometimes both equations by something, so I can set that up to where I have the opposite sign coefficients. 3, you just add the equations down. 4, you solve for whatever variable that's remaining. And then 5, you go back and you substitute in that solution you got and you solve for the remaining variable. So these are the 5 steps. Unfortunately, I can't keep this up throughout the whole video, but if you need to write this down, you can. But hopefully this makes sense. Okay, so step 1, is this in standard form? Yes, they're both in standard form. Step 2, can we multiply one of these equations, both sides by something, right? Because we can't eliminate anything now. So we have to multiply both sides of one of these equations, or possibly both, by some number so we can set this up to where we can eliminate a variable. So I'm looking at this top one and I'm thinking I can multiply both sides by 3, right? Because that'll give me 21x minus 21x, that's 0. But wait a minute, that'll also give me 6y minus 6y, which is 0, right? So this is another advantage of elimination, is those cases where you have no solution and infinitely many solutions. Oftentimes they jump out at you. They jump out at you a little bit more than they do when you're doing substitution. They're a little easier to notice. So let's go ahead and do the whole process. I'll multiply both sides by 3 times 3 times 3. So what am I left with here? 21x. I'm rewriting this down here. 21x plus 6y equals 16 times 3, that's 48. And again, when I add down, look what happens. I have 0 plus 0 equals 24 plus 48, that's what? 72. 0 equals 72, right? Isn't that what I'm left with? 0 equals 72, which is a statement that is what? Never true, right? 0 doesn't equal 72. This is nonsensical, right? So, no solution. This is an inconsistent system of linear equations. All right, so for this example, we already see that it's in standard form, so we're good to go. So I'm looking for a number that I can multiply. I'm going to use this top equation, multiply both sides by something, so I can eliminate one of these variables. And it looks like -3 is going to work, because -3 times 2 gives me -6, and -6 plus 6 gives me 0. So I'm going to multiply both sides of the top equation by -3. -3. But as we can see, a similar thing happens as the last example, because look what's also going to happen. This is going to become +3, which will cancel with this y as well. So both the variables will go. We'll be left with -6x plus 3y equals -9. I don't know why I drew that line there. I was supposed to draw it here, because this is where I add down. 6x plus -6x, that's 0. Plus -3y plus 3y, that's 0. Equals 9 minus 9, that's 0. So we have 0 equals 0, which is always true. So in this case, we have what? Infinitely many solutions. It is a dependent system. Infinitely many solutions. Dependent system of linear equations. Okay, so with elimination, and with the cases of no solution and infinitely many solutions, both our variables cancel. So we're always left with 0 on the left side of the equation, right? So we just have to look at what's on the right side of the equation. If we have 0, then we have 0 equals 0, and we have infinitely many solutions. If it's anything other than 0, then we have something that is never true, and we have no solution. All right, for this last problem, I encourage you to pause the video and try it on your own. Then press play so you can check your answer. So let's go ahead and start. I'm looking to see if these are in standard form. In this case, they are, so I'm good to go. So let's see, I'm going to work with this top equation, and I'm going to multiply both sides by -3. I'm just going to get rid of these x's, and that's going to be good. So -3 to both sides. -3. -3. So what am I left with? Let's see, -3 times 2x, that's -6x. -3 times y, that's 3, it's -3y, right? Equals 20 times -3, that's -60. Now I can add, and my x's will eliminate. I have 0, -5y plus -3y, that's -8y, equals 12 minus 60, that is -48. Now if I divide both sides by -8, I can get the y by itself, -8, right? And I have y equals, let's see, 48 divided by 8. 6 times 8 is 48, so that's going to give me 6. So now I can go substitute this back in. Let's see, which one should I pick? I think I'm going to use this original one, 2x plus y equals 20. So since 2x plus y equals 20, I can do 2x plus y equals 6. So I'm going to substitute in 6 for y equals 20. Now I can solve for x. So I'm subtract 6 from both sides, and I'm left with what? 2x equals 14. And now I can divide both sides by 2. That gives me x equals 7. So I have one solution. This is an independent and consistent system of linear equations. And I have x equals 7, y equals 6, and I can write that as a 0.7, 6. Alright, so hopefully this video helped. Hit thumbs up if it did. Make sure to subscribe for more. Leave any questions below. Keep flexing those brain muscles. I'll see you in the next video. We'll make some more brain gains.